Welcome to Physics Fail.
Now, hello everyone, welcome to Physics Well. Now, today we are going to solve one question from Electric Field and Charges, class 12. Now, the question is that the two charges of equals to Q, they are kept at x equals to minus a and x equals to plus a on the x-axis. A particle of mass m and charge q naught equals to q by 2, it is placed at origin. If the charge q naught is given a small displacement along the y-axis, so you have to calculate the force that is acting on a particle, and it is proportional to which quantity? It should be proportional to y, or it should be proportional to minus y, or 1 by y, otherwise minus 1 by y. We have to choose the correct option. It is the MCQ question that was already asked in JEE or NEET. Okay, so we are just going to solve that question here. So at first we should make a diagram. We have to take help of coordinate axes, right? So this is our coordinate axis that we have drawn here. In this case, there are the two charge particles. They are having the same charge and they are placed at these 2 points. This is your x equals to minus a. This is your x equals to plus a. This is the charge of q and there is the same charge of q. They are placed by some distance, that the total distance between these two charges, that is of 2a. But the distance between these two charges will not be used here. In this case, initially you are placing another test charge that is having a value of q naught, and it is having the value of q by 2 initially at origin. Whenever you will place another charge at the origin, they are equidistant from these two charges. So the force, the total force acting on the charge, whenever it is placed at origin, that will be equals to 0. But whenever you are placing the charge at some distance in the y-axis, suppose at this point I'm just placing the charge, it is having a magnitude of q naught. So we have to calculate the distance of q naught from each of the charges. In this case, this is the distance, we can say, right? So at first we should calculate the distance here. Initially, the charge q naught was displaced from the origin by a distance of y, right? And we know that much distance of the charged particle from the origin, that is of a. So we can say that the distance between these two charged particles, that is of under root of y square plus of a square, right? We'll obviously apply Coulomb's law to find out the value of the force, but in this case what happened, all of these three charged particles are positive in nature. So this q will apply a repulsive force on this q naught in the outward direction like that. Similarly, this charge q will also apply a repulsive force on this q naught in the outward direction like that, right? So in this case, we have to just break their components so that we can find out the total force. As you can see here, that there is an angle with respect to this y-axis. We can say that there is an angle of theta which is acting here. So if it is the angle theta, so along this f sine theta component will work, and along the base obviously f cos theta component will work. Similar case we'll find for this force also. This is the angle of theta, and along this direction f sine theta component will work, and along this direction another f cos theta will work, right? Now the diagram is so dirty, I'm just explaining again. Now in this case, as you can see, if we just separate this part, so this is the force, this is the one of the repulsive force, this is another repulsive force, that is of f. This is my y-axis, okay? So with respect to the y-axis, we can say that this is the angle theta. So we know along this line, if cos theta component will work for this force, and along this line, if sine theta component will work. Similar case we'll find out for this force also. If this angle is also theta, so we'll get another f cos theta component along this and another f sine theta component along this. So as you can see that f sine theta components are equal and opposite with respect to each other. So they will cancel out, right? And we are getting the total force. The total force, as you can say, as F dash, that is equals to, we are just taking F cos theta plus of F cos theta. So that is of how much? That is of 2F cos theta. In this case, that much angle is theta, right? So we can say this angle is also theta. So what is the value of cos theta with respect to this angle? Cos theta is having the value of base by hypotenuse. With respect to this angle theta, base is y and hypotenuse is under root of y square plus of a square. So we can say this is of 2 multiplied by, what is the value of force? Force is 1 by 4 pi epsilon naught. That will be q multiplied by of q naught. As these two charged particles are separated by some distance of under root of y square plus a square. So we'll only consider this divided by under root of y square plus of a square, that whole square, multiplied by the value of cos theta. The value of cos theta, that is of y under root of y square plus of a square. This big expression will be of no use. We just have to find out the force which is proportional to which quantity, y minus y, 1 by y or minus 1 by y. We have to find out that thing only. So in this expression, we are just going to simplify it. Okay. So if we simplify, we can say this will be 2q q naught multiplied by of y divided by of 4 pi epsilon naught, and it will be y square plus of a square whole to the power of 3 by 2. And in the left hand side, you just write down the total force. In this case, the total force I am representing with F dashed. Okay. Now, as you can see, this F dash is directly proportional to y only, right? So we can say that first option is correct and the total force F dash is directly proportional to y. This is the correct answer. I hope you have understood the solution. If you have any problem in understanding that, just comment me fast. I will explain again. Thank you so much.